if you design a drive on IGBT and then switching to silicon carbide and increasing the switching frequency, you have the possibility that you don't need to derate your drive. So you will get out more power with a higher switching frequency. We have this .xt interconnection technology where we can bring the power cycling to a stability, a minimum of the IGBT7, and at this time it looks that it is even better.
This is the Podcast for Engineers, the podcast you just have to listen to if you're interested in what's going on in the semiconductor market. My name is Kelsey Markl, and today I'm joined by our Global Application Manager for Industrial Drives at Infineon, Wolf-Dieter Bähre. Wolf-Dieter, thanks so much for being here.
Kelsey, thanks for having me.
Great. We're going to be talking about silicon carbide and more of a traditional application, industrial drives. Why has it been taking so long for silicon carbide to really make its mark in industrial drives?
So, as you said, industrial drives is quite traditional, and it still takes long to get used to silicon carbide because there is not this unique value like in other applications. First of all, we have the efficiency standards. All drives have the highest class in efficiency that is defined today, and so there is no push by regulation to have a more efficient switch in the drive. And that leads to the situation that you need another value. And so our customers need to find a value that suits the application, like in integrated drives, where you have the possibility to have higher rated output current with the same heat, like if you use an IGBT. So there you can use directly the benefit of silicon carbide.
Yeah, because I think we all know it's still the case that silicon carbide is a little bit more expensive than silicon as a material. So some of the components may be more expensive. So you're saying that now our customers are realizing this return on investment may be achieved?
Yes. As I said, it's a special case. So there's not directly a value if they just have the most efficient drive, but if they can utilize it to make to get more out of a servo motor, for example, where the drive is directly mounted on the motor, then it gives a direct benefit for our customers, and they can bring that to the market.
Okay. You mentioned some of these servo drives, for example. Do we already see early adopters, pioneers in silicon carbide in application?
Yes, we do see pioneers that have figured out this value, that they have less heat that they need to get out of the inverter section, and then they go for silicon carbide in the application.
Okay. I can imagine that still switching technologies from silicon to silicon carbide can still be a hurdle for some companies or for some engineers that are used to designing with silicon. Do we offer anything? How can we help them get over this learning curve?
So the first thing that we do is we offer evaluation boards and reference designs. So the first thing, just to show the technology and then also to show how it works in the system. And that reduces really the time, the design in time at the customers. And we have feedbacks that with the reference designs, they can reduce the design in time by around 50%.
Okay, yeah, that makes a huge difference, I guess.
Yes.
Do we offer anything less hands-on? Any certain documentation or anything new in that space?
To support it a little bit, we do have white papers, for example, where we explain also the differences between silicon carbide and IGBT, and also the return of investment if you compare it to a more efficient motor.
Okay, that white paper is relatively new, right? I'll link it in the show description, or People can find it on our website, I guess, right?
Yes,
Okay.
that's great.
What about silicon carbide? Besides maybe the design hurdles, are there any technical challenges to using silicon carbide in drives?
Yes, the switch itself has, for example, a lower short circuit capability.
Mm-hmm.
And you need to be aware of if you design it in. That's also a reason for that we see it more in integrated servo drives, because there you don't have the motor cable between the inverter and the motor. And then you can handle this very short circuit times better. And on the other hand, we are working on to deliver a solution that that will overcome this hurdle directly for the customer.
Okay, is this something that's required by the industry? Some sort of short
Yes.
circuit robustness?
There is a standard for electrical safety,
Mm-hmm.
and there it is required. If you have the drive and then a cable, you need to have some short circuit robustness.
Okay. So you mentioned short circuit robustness. Is there anything else? Power cycling, I think that we had talked about in the past.
Yeah, that's right. Power cycling, that's very demanding in drives, because we have very demanding load cycles, fast acceleration and deceleration, and so that's a very, very important part to cover also the load cycling.
For load cycling, when we had conversations about this in the past, I'm not an expert, but I remember in servo drives you mentioned the robotic arms, for example, having to start and stop very quickly. Is there anything that serves this power cycling? Any kind of packaging technology or connection?
Yes, we have this .xt interconnection technology, where we can bring the power cycling to a stability, a minimum of the IGBT7, and at this time it looks that it is even better than the IGBT version.
Okay. You mentioned IGBT. We don't want to completely forget about IGBT. Is there anything new in that front when it comes to industrial drives and automation?
Yeah, as I mentioned before, IGBT is still very, very important in drives. So we have a look to how to improve it further. We have, for example, a new thermal interface material where we can improve the RTH a lot. And that's one of the examples that we do to improve also that technology.
Okay. What is different about this thermal interface technology?
Oh, it's just it's a new material.
Okay.
And we are able to increase the efficiency, with a very small change for the customer.
Okay, so now that we've talked about IGBT and silicon carbide, it sounds like we have solutions for both technologies for our customers. Does that benefit them?
Yes, it benefits them a lot. For example, if you look at a normal case in drives, you have a switching frequency curve. So if you increase the switching frequency, you will decrease the output current. And if you design a drive on IGBT and then switching to silicon carbide and increasing the switching frequency, you have the possibility that you don't need to derate your drive. So you will get out more power with a higher switching frequency, and that benefits everyone if you build a drive. So you have this possibility available.
Okay, Wolf-Dieter, so it sounds like we have everything the customer needs, whether they're ready to design with silicon carbide or if they're still designing with IGBT. If I were a customer and I'm designing right now something new, what would your advice be to me?
Oh, first of all, check out our reference designs. So we have the technologies, silicon carbide, IGBTs, and even gallium nitride if you want. And on the other hand, we do provide reference designs for modules, for discretes, for IPMs, even for molded modules. So you will find a very good starting point to develop your drive. And if you have more questions, then reach out to us.
Okay. Thank you so much for being with me, Wolf-Dieter.
Thanks for having me.
And to our audience, if you're interested in learning more about silicon carbide and industrial drives, please check out our website, infineon.com/industrial-drives. We have lots of resources there, including an upcoming webinar on the topic. So I'll include everything in the show notes below, and please stay tuned for future episodes. Thanks a lot.